Hello and welcome to our ACHEMA webcast. Can you feel it? ACHEMA is in the air. Only 2 weeks from now, on Monday the 22nd, the Frankfurt Fairgrounds will be buzzing with activity, and you will have the chance to explore all the technologies and the solutions that our exhibitors have prepared over the last 3.5 years. So we are really excited about this run-up to ACHEMA and about all the preparations going on. And in order for you to prepare a bit more and get some insight on the trends that shape and change the process industries, we will cover one of them again today in our webcast. And you have the chance to join. Just go on Slido, use the hashtag ACHEMA Highlight, ask your questions, and I will pass them on to my guest. Now, two of the big issues over the past years for the chemical industry have been becoming circular, closing those material cycles, and on the other hand, mastering the energy transformation. Both of them maybe have been overshadowed over the past weeks and months a little bit by the gas crisis. But are those really different questions, or aren't they just different sides of the same coin? Well, this is what my guest today says, and I will talk to him about it in a minute. He is a chemist by training, started his career at DSM in several roles where he dealt with sustainable chemistry. Today, he's a principal consultant at TNO with a focus on the industrial transformation. Welcome, Reinier Grimbergen.
Hi, good afternoon.
Hello, great to have you with us here today, Reinier. Now, as I just said, over the past couple of years, we had the energy transition on the one hand, we had the question of circularization on the other hand, and maybe we treated them sometimes as separate goals, but you say both of them have to be integrated. Where do they come together?
Yeah, first of all, thanks for your kind invitation to join your webcast. It's basically the answer to the question is behind me. You see two spheres. On the right-hand side, decarbonized energy, the energy transition, and on the other side, the feedstock transition, which is all about going to circular feedstocks. And where do they meet? I maybe have to put my the big thing in transport and storage, effectively, and that is transport and storage of molecules and of electrons, so electricity. And that is basically what connects them together. And that means also infrastructural challenges compared to the situation today, looking forward to what the industry will be in the future. But I think we come back to that later.
Okay. But what type of processes do we really have to target where we have the biggest levers for the transformation to happen?
Yeah, very nice question. I think the biggest lever for decarbonization, for the climate mitigation, is in fact decarbonization of the energy that is used by the industry. So the biggest handle is electrification, with capital E, I would say. And that is about processes with a motor, first of all, because thermodynamically anything with a motor runs on electricity very energy efficiently. So we gain effectively for free a factor 2 of energy. That's super. And then you can think about, of course, cars, but also in the industry, heat pumps, which also contain motors, and high temperature heating, like e-crackers, like an steam methane reformer. So anything that heats as well. And then next to that, related to electricity, is of course green hydrogen that everybody talks about. And rightfully so, because that you can use if electricity doesn't work. So it might be in some specific high temperature processes to use it for high temperature heating, or for instance, the fuels where we cannot substitute fuels by electrification. You can think about aviation, of course. So then hydrogen kicks in, but hydrogen you can read as electricity as well, but then in the shape of a molecule.
And that's quite impressively shown in your graph there. I just want to remind our audience, if you have any questions, just go on Slido, use the hashtag ACHEMA Highlight and ask your questions. I will see them right here and pass them on. But in the meantime, let's get back to this field in the middle where you have the hydrogen and the energy. Now, if I look on the circular feedstock side, I see we can decarbonize energy. We can't decarbonize the chemical industry. We need carbon, of course. Now, there are several opportunities for sources of carbon. We have CO2, we have biomass, we might have other sources as well from chemical recycling or whatever. how do you think will be the share of those sea sources in the future? What will we be using mostly, or will we be using just one of them even?
Yeah. Yeah, that's of course what everybody is looking at. How do we get from and I give you an example. In Rotterdam Harbor in the Netherlands, we import 100 million tons of oil, and 80% for that is going to fuels and 20% to feedstock for the industry. So we're talking really big numbers. And if you think how can we substitute that, then you have to think about going to circular carbon, meaning non-fossil. And in the end, that is to close the material loops for the industry. And then you have to think about biomass, about waste, and about CO2. That's the three. That's simple in a sense for a chemist. The good news is we can make all chemistry out of that. So that's super. And then there's, of course, you can ask the question, okay, where should we send this carbon, which is then a bit scarce, where should we send it first? And there is a study that's more about, of course, political, societal decision making, because then also other elements come into the equation. And then from a Dutch report, from the Social Economic Board, there is a kind of merit order, like you should first have food, then textile materials, raw material for chemicals, then heavy transport fuels, then high temperature heat, low temperature heat, light transport fuels, and in the end, electricity. So that's an interesting merit order. I think especially these days, but you're looking, you can challenge it, and that's of course geopolitical. That can also change orders, but that is a kind of in between brackets accepted order that these type of studies show.
But if we have a sea source, or if we have the choice between several sea sources, we have the biomass, we have the CO2. As you said, we can make everything out of each of them. We just need energy and maybe a bit of chemical processing. But I guess not every pathway is recommendable. For example, using biomass to create CO2 and then to convert it into chemicals might not always be the best solution. So how can we determine what to put where to use which source of carbon?
Yeah, there are of course various ways. The market will determine it. Where will people pay for? And that, of course, we have seen that the market doesn't do its job properly yet on, I would say, circularity. But then you see incentives coming from the European Commission, like the Green Deal, Fit for 55. So these things will change by CO2 taxation or the ETS price. They will start to change the order of the cost order, if you like. So that is going to change. But then, for the industry is basically the raw materials that are needed first, and that will compete, of course, with fuels. If you talk about carbon and how that will unfold, I think that needs a regulator, in fact, to make sure that we have a level playing field for carbon going towards fuels and carbon going towards materials, for instance, polymers, plastics, whatever. So there is a regulatory role in that, I think, and it's also a societal acceptance role related to the regulator, of course.
So if we look back on our last couple of minutes of discussion, we mentioned, I think, a couple of times that with enough energy, we can do everything. One question that always arises, probably our audience are asking it right now too, where will all this renewable energy come from?
Yeah, that's a very good question. And I think the answer is, I'll come back to that later, is that this is, of course, scarce still. We are talking in the Netherlands about, I think, about 10% of the electricity, or 16% currently being renewable. That's a fraction that has to grow, because if we're going to electrify, then also other sources of heat, of fuels, will have to be replaced by electricity. So we made a calculation. If we want to decarbonize the industry, transportation, and some heating in the Netherlands, and we want to achieve 50% emission reduction by 2030, then you talk about approximately the total electricity that is being produced in the Netherlands today that has to be added green to meet that target. So that gives a bit feel for, we are talking big numbers. It's not impossible, but it's a huge challenge. Where does this electricity then come from? That can, of course, be from solar, wind, hydro, maybe geothermal renewable energy, and nuclear. Again, I think an elephant in the room here at the moment with everybody. You can have your opinions, and that is fair. Everybody can do it, but it's of course also low carbon. And that's an ongoing discussion, but I think it also nicely exemplifies that making decisions in all these areas is always about dilemmas. You win, you lose. And I think for the public opinion and for all of us, it's important to know that whatever you choose, you get benefits and you get disadvantages. And there we have to navigate properly through to have the best possible way for the industry and for society.
Mm. Yeah, I think we are just experiencing some of the dilemmas we may have been discussing in science already for some time. Now it's in the political and societal room already. The role of the chemical industry so far has been mostly discussed in terms of, well, being at the receiving end, using carbon, using energy, requiring gas or other resources. But could the chemical industry also become an active driver for the whole transformation?
Yeah, sure. As a chemist, I'm an optimist, and I believe in chemistry, so that's my bias. But the thing is that chemistry can bring performance, and therefore, for instance, if you think circularity, more durable products that will help to have less disposal. That's very important already in the value proposition today, I would say, and it can help even the customers or the end consumer. If you talk, for instance, fuels, is their scope 3 emissions. If you bring in circular carbon like CO2-based fuels or bio or waste stuff, that's possible. So then you basically help your customer or the client of your customer to decarbonize their business. So there is multiple value propositions that the chemical industry can bring in the value chains we're active in.
So if we take all this into account and try to envision the chemical side of the future, chemical side in, let's say, 2050, what will it look like compared to today?
Yeah, that's the $1 billion question, of course. When you ask me, my personal view is it will be highly electrified, first of all. And secondly, I think we will see next to oil that will still be there for certain products. We will see new platform or global commodities, which could look like, I mentioned them as the usual suspects, like methanol, which you can produce from all these feedstocks, like ammonia as a hydrogen carrier and a nitrogen source, and for instance, pyrolysis oil from plastic waste that can be processed decentral and can lead to a pyrolysis commodity feedstock across the globe to process in the plant. So that is what it will look like me. And I think there will be, because of the electrification that is more decentral, probably also the industry will to some extent decentralize. I don't believe in that for the big feedstock processes so much, but for more specialty products that becomes more easy. Yes, that's my personal view. And then to come to really to net zero, that's important. We will also need net negative technologies, the negative emission technologies, because there will always be some residual emissions. And then you can think about CCS or bioenergy CCS, stuff like that. And we will see a CO2 infrastructure for storing, but also for using it as a feedstock, like we will see for hydrogen or hydrogen carriers. Long answer. I hope it gives a picture.
It gives a picture, certainly, but it also shows, I think, some of the challenges we are facing. I mean, it's not only about technology. When you say the whole structure of the industry is going to change, we need a CO2 infrastructure. It will change the way our landscapes look, the industrial regions look. It will also take some societal and political discussion, I suppose. So it's important to get started or to get faster than we are today. And I hope we can make a contribution with Achema, with our talks there. And I'm really looking forward to seeing you there. It's exactly in 2 weeks' time. It's exactly 2 weeks' time. It's on Tuesday, the 23rd at 1:30 p.m. Then we will have a highlight discussion with Reinier and with Marco Bosch from BASF and with other industry experts. And I'm really looking forward to it and to seeing you there. So goodbye for today and see you in 2 weeks.
Okay. Thank you. See you there.
And for all of you who want to learn more and experience more, join us at Achema, not only for the highlight session. The highlight session on Tuesday, the 23rd, is part of a whole theme day on fossil-free production, about carbon neutrality, about power-to-X concepts, about CO2 use, and everything else you can imagine. We have more on sustainability, of course. On Monday, the 22nd, the first day of Achema, we have a theme day on hydrogen and hydrogen usage. And we have our opening session, which is labeled towards a C-neutral chemical industry by 2040. So join us there as well and hear what the experts have to say. And if you're interested more in the circular side, in anorganics and biomass, you might want to join us for some of our sessions on Thursday, the 25th, where we also have a focus on the circular economy. And of course, you can see solutions and technology for all of this all week long in the exhibition. So make sure to get your ticket today, download the Achema app to prepare your visit, and I'm looking forward to seeing you at Achema.